Assalamu alaikum dear students. Today we are going to discuss one of the most important chapter of this course, which is limits and derivative. Now firstly we will discuss limits. In functions, if we have a set A with elements A, B, C and there is another set B, and if we consider a rule f from A to B such that under this f A is related to B, that is A is related to B, B is related to another element, and C is related to an element which is outside this B, then clearly you know that C does not belongs to the domain of this f, or simply we can say that this function f is defined at x equals to A and x equals to B, but function is not defined at x equals to C. Like if we consider a function f from or to or by f of x equals to 1 by x, then clearly at x equals to 0 the value of this x equals to 0 for this function is infinity. This infinity does not belongs to or, that is why we say that this x equals to 0 does not belongs to the domain of this f, or simply we can say that f is not defined. Now if we consider a function like, for limits, if we consider a function f of x equals to x plus 1 where x is not equals to 0, so this means that this 0 does not belongs to the domain of this f. Clearly we cannot find the value of this function at x equals to 0 because the function is not defined at x equals to 0. Now question arises, what might be the value of this f at x equals to 0? That is, can we find the approximate value of f at x equals to 0, or simply what might be the behavior of this function at x equals to 0, that is how value of this function looks like. For this, in order to check the behavior of this function at x equals to 0, we need to check the behavior of the function at the points which are close to 0, because at points which are closer to 0 the function is defined. Since there are two types of points which are closer to 0, those points from right side and points from left side. Now the points from left side are slightly less than 0, like if we have minus 0.1, minus 0.01, minus 0.001, so etc. All these points are less than 0, but they are very very close to 0. Similarly, if we have the points like 0.1, 0.01, 0.001, these are the points which are greater than 0 and which are very very close to 0. Now at these points the function is defined, so we can find the value of the function at these points. Now the points which are closer to 0 from left side, that is which are less than 0, like minus 0.1, value of the function is f of minus 0.1, that is minus 0.1 plus 1, because function is defined by f of x equals to x plus 1, which is 0.9. Similarly at x equals to minus 0.01, value is 0.99. Similarly at minus 0.001, value of the function is minus 0.999. so this means that there are infinitely many points which are closer to 0 from left side, that is which are less than 0, and the way we can find the value of the function at those points. So all these points are close to 0, that is less than 0, and lies left of this 0, that is from the left side of this 0 all these points lies, that is on the negative side, because on number line the left side is taken to be negative side. This means that when we get closer and closer to 0, that is when we approach to 0, from left side, that is at these points, because minus 0.1 minus 0.01 is much closer to this 0 than 0.1. Similarly, minus 0.001 is much closer to minus 0.01. So this means that when we approach to 0 from left side, that is this, we can write this statement as x tends to 0 negative, or x tends to 0 minus. This means that we are taking, or we are considering those points which are closer and closer to 0, but which are less than 0, because there are infinitely many points. So this means that this statement x tends to 0 negative represents infinitely many points. Now at these points, the value of the function is minus 0.9, 0.99, 0.999. So this means that the value gets much closer and closer to 1 as we approach to 0. That is when we approach to 0, because this minus 0.1 is less than minus 0.01 is less than minus 0.001. That is whenever we approach to 0, the value gets closer and closer to 1. So this means that when x tends to 0 negative, the value of the function at these points tends to 1. That is f of x tends to plus 1. So this means that this 1 is not here the actual value, it is simply the approximate value, because from these 3 points the value is not equals to 1, but value is very close, very close to 1. So this means that whenever x tends to 0 negative, that is x tends to 0 minus, f of x tends to 1. So this means that whenever we approach to 0, the value of the function approaches to 1. So this means that here 1 is not the actual value. This is called as, this one here is called as left limit of f at x equals to 0. Now at all the points which are closer to 0 from right side, this means that those points which are slightly greater than 0, and there are infinitely many points which are greater than 0, like 0.1, 0.001, 0.001, 0.0001. So this means that at these points the value is 1.1, 1.01, 1.001, so on and so forth. So this means that whenever we approach to 0 from right side, from the value approach to 1.1, 1.01, 1.001, it tends to approach, or it simply approaches to 1, because 1.1 in approximation we can write this as 1, 1.01 we can write this as 1, 1.001 this can be written as 1. So this means that whenever we approach to 0 from the right side, the value of the function approaches to 1. That is, at all these points from positive side of 0, x tends to 0 positive, infinitely many points, value of the function is 1 point, that is value of the function tends to 1. So this can be written as, that is whenever x tends to 0 positive, f of x tends to 1. This 1 is not here the actual value, this is the approximate value, because we are not taking x equals to 0, we are considering only those points which are either less than 0 or which are either slightly greater than 0. This one here in this case is called as the right limit of f at x equals to 0. So whenever left limit equals to right limit, then we simply say that at that point limit exists. That is, if we have a point A, that is whenever x tends to A positive, implies f of x tends to L, and at x tends to, when x tends to A negative, f of x tends to L, then this L is called as the limit at x equals to A, and we simply denote this by x tends to A implies f of x tends to L, or simply limit x tends to A, f of x is simply L. So limit simply means the approximate value or the nearest value, because you can from above example it is clear that this is not the actual value. So inshallah, in tomorrow's video lecture we will discuss further few examples to explain this very concept. So thank you.